So good news, no graphing today. But I want you to keep in mind that when I give you a system, I'm giving you two equations for two lines, and our ultimate goal is trying to find where they cross. Now we're going to do that without graphing from here on out. So the reason why we're not graphing is great, but when you're trying to be really precise and find a very specific point, if you're not really accurate with your graph, it's easy to miss, which was kind of the point of yesterday. So moving forward, we're not graphing any of these. As a matter of fact, I don't even think you're going to be asked to graph anything on your test when we get to the end of this unit in about a week and a half. So today we're solving by what's called substitution. Literal substitution. We're going to take one thing out and put something else in its place. Just like when you have a teacher absent for whatever reason, they usually bring in a substitute, someone to fill that spot. That's what we're looking at here. So Monday and Tuesday, I gave you two equations, both in slope-intercept form. So when you're solving these systems, it kind of depends on how they're presented to you. If I give you a system where your both equations are in slope-intercept form, it probably would be best to graph them and check your solution. However, there's different methods for the different ways they're given to you. So today I'm going to give you an equation, one in standard form and one in slope-intercept form. We didn't do a whole lot with the standard form of the equation other than turn it into a slope-intercept form to graph it. But just real quick review, the top one here, y equals 7x plus 22, that is in slope-intercept form. The 5x minus 8y equals negative 23, that is in standard form. Now that top equation, the y equals equation, that's what we're going to use for our substitution into the other equation. Now what I mean by that, this top equation says I've got a single y variable equal to this bigger chunk here on the right, 7x plus 22. So in my second equation, I can remove that y variable and slide in that bigger chunk of 7x plus 22. So I'm going to do that. The 5x is going to stay put. The minus 8 is going to stay put. And then where the y was at, oh man, that's making a mess. Where the y was at, I'm going to put in that whole chunk of 7x plus 22. That still equals negative 23. So what you've done is you've taken a single variable out and you've substituted a bigger expression that was equivalent to that single variable, right? The y equals 5x, or 7x, you can trade those two things out left and right. So when I do that, I create this bigger equation, physically bigger equation, but if you notice, it only has one variable in it. And from what we did previously in the year, I can solve an equation that has a single variable in it. They're all x's. So I'm going to distribute my negative 8. That's going to give me negative 56x minus 22 times 8. That's 176. 176 equals negative 23. And just piece by piece, you're kind of whittling this down and making it easier to look at. Combine your x terms. That's negative 51. And then I'm going to add 176 to both sides. That's going to leave me positive 153, which is great because now when I divide by the negative 51, I get an x value of negative 3. So what that means is when we're looking at a point, my x coordinate for my solution is negative 3. Now I just have to figure out what the y value is. The good news is the y value is always easier to find than the x because I'm going to substitute again, but this time I'm going to go back to this original slope-intercept equation, and I'm going to trade out the x this time for a negative 3. So when I evaluate that, that should just be a straight computation. You shouldn't have anything to solve for. 7 times negative 3 is negative 21, plus 22 is positive 1. So my solution is negative 3, positive 1. Now you can verify these just like we did yesterday. You can take the xy values and plug them into your two original equations and see if they work out. This does. I'm not going to ask you guys to go back and verify these, but you can, and if you do, it basically makes sure that you're not going to miss any of these, because if you miss one, you can go back and check your work. right? I realize that this is kind of a long process, but after you do a couple of them, it gets to be pretty quick. So kind of the general steps are out here. The 1 through 4, that's what this is. Just kind of my thought on how to do this. But I'm going to go through this one pretty quick. I'm going to take out my y value from my standard equation and put in negative 2x plus 11. That equals 2. I'm going to distribute. So that is a negative 4x plus 22 equals 2. Combine my x terms, so that's negative 5x. Subtract 22. So that's negative 20. Divide out my negative 5. My x value is 4. So in my solution, my point is 4, comma, I just need to figure out the y. The y, if you've got a calculator, you can literally do this on your calculator. I'm going to plug in for my x value in my slope-intercept equation, 4. So negative 2 times 4 is negative 8 plus 11. That guy is 3. 4, 3. Okay, these aren't going to get any more difficult than this. The hard part is if you have to distribute a negative when you multiply in. So just be careful on these. These will all work out to be whole number or integer points. You're not going to get any fractions or decimals. So if you made a mistake, that's a real easy place to check and see if you goofed. No decimals, no fractions.